Okay, ladies and gentlemen, first I'd like to start by reviewing a concept that you learned about a week ago. And this was using some special patterns. One we called the sum of squares, the difference of squares, and the product of a sum and a difference. And what we did is anytime we saw a pattern that looked like this, we squared the first number, 2 times the first number times the second number, and then we squared the second number. Same thing with the subtraction, except you had a subtraction sign. And then when you had an a plus a b and an a minus a b, it was just a squared minus b squared. So real quick, let's see if we can practice those. Push pause and give it a try on your own. Okay, so number 1 is the first pattern. So we're going to do n squared plus 2 times n times 9, which is 18n plus 9 squared. Number 2 is the second pattern. So we're going to take r squared minus 2 times r times 11 plus 11 squared. And number 3 is the last pattern. You take the first number squared minus the second number squared. Alright, so let's take a look at today's goal. Today we are factoring and solving binomials that are the difference of squares. Okay, so the difference of squares, that means we're going to be focusing on the third pattern here, because the answer is the difference of 2 squared numbers. Okay, so that's going to be this pattern that we are looking at. So we're going to be going backwards today. We've been able to do products, but today we are factoring. Okay, so I want you to be able to go from z squared minus 169 to z plus 13, z minus 13. That's the factored version. Okay, so let's take a look. The idea is that if you have a squared minus b squared, you can rewrite it as the product of a plus b times a minus b. So let's try one. Okay, so with the first example, we've got m squared minus 64. So in your mind, you're always going to be thinking about the square root of each of those things. First, check to make sure it follows the pattern. Is it a squared minus b squared? Yes, because 64 is 8 squared. So we can rewrite this as m squared minus 8 squared. Now it'll be really easy to rewrite it in the pattern. It is m plus 8, m minus 8. And we factored it. The easiest factoring of your life, right? Okay, let's try letter B. So here we've got more numbers. So we've got 4 squared y squared minus 9 squared z squared. So when we write it, it's going to be 4y plus 9z times 4y minus 9z. Easy, right? Okay. Letters C and D say solve. So these are going to be a little bit different. We're going to have to take an extra step here. So with x squared minus 36, that's x squared minus 6 squared. So we can rewrite it as x plus 6, x minus 6 equals 0. It's factored. Now I need to check, is it a times b? Yep, so I can use the zero product property. And then I can solve each of those to find out that my final solution is x equals negative 6 or x equals positive 6. Try letter D, all by yourself. All right. first thing I notice is it's not the pattern. It's not something squared minus something squared. However, I see a common factor. I can divide out a 3b. So I'm starting with dividing out the 3b. That gives me 3b, b squared minus 9 equals 0. Okay, second step. Now I see the pattern of a squared minus b squared. It's b squared minus 3 squared. So we're going to write this as 3b, b plus 3, b minus 3 equals 0. And now we can use the zero product property to solve. Either 3b will equal 0, b plus 3 will equal 0, or b minus 3 will equal 0. So b equals 0, b equals negative 3, or b equals positive 3. That was pretty challenging, right? So remember, when you're solving these, when you're factoring anything, the first thing you want to ask yourself is there a GCF? You always need to get rid of that GCF first. Then you can go ahead and factor. Then you can solve. Okay? Let's try another problem. All right, so in this case, we're going to apply a technique more than once. Now, this is a challenge. I just want to bring your brains out to this world. You won't necessarily see it in tonight's homework, but it will come up eventually. Okay, so is this a number squared minus a number squared? Well, it is. It's y squared squared minus 25 squared. Okay, so when I rewrite this, this is going to become y squared plus 25 y squared minus 25. Now this first chunk is not a pattern that we're familiar with, but the second chunk is. So we're going to continue that pattern. That's y squared minus 5 squared. So it's y plus 5, y minus 5, and we write that first one that we couldn't factor more. Isn't it beautiful? All right, let me show you another challenge. Okay? This one again has to do with checking to see if there's a GCF first. We notice that these two terms can be divided by 9x. So the 9x goes on the outside. We get x to the 4th minus 36 divided by 9 is 4. And then we can factor this because it's a squared minus b squared. So we get 9x, x squared minus 2, x squared plus 2. Now in this case, 2 is not a number squared, so we can't continue there. So this would be my final answer. All right, so homework tonight. 1 through 4, 15, 19, 24, 20, 48, 49, 54. It's a total mess of things, but I've cut and pasted it all together, so you just need to follow through. Please number it as shown. That'll help you when you're checking it.